EVPN is a powerful technology, and the basic idea behind it is not hard to understand, but it can be a challenging technology to deploy. Today, I want to show you how you can make deploying EVPN a lot simpler with the right kind of orchestration. These days, Ethernet is everywhere, and when you need to stretch Ethernet beyond the traditional local area, EVPN is the solution you want. EVPN provides per-flow redundancy, all-active load balancing, and fast convergence, using the same principles and operational models as Layer 3 VPNs. Whether you're providing ELAN, E-line, and IRB services across the WAN, or planning for workload mobility in and between data centers, EVPN provides optimal forwarding with fewer protocols. To the end user of an EVPN service, everything looks simple. It's just Ethernet. But behind the scenes, the network is working hard to provide that seemingly simple service. Many settings have to be coordinated among many devices in the network. For even the simplest EVPN virtual private wire service, or VPWS, a configuration workflow has many steps. Orchestration folds all of those manual steps into an automated process, ensuring that network settings are properly coordinated, reducing the amount of human input and thus inevitable human error, and automatically implementing known best practices. There are lots of ways to automate and many choices when it comes to orchestration. Cisco's Network Services Orchestrator, or NSO, has multiple benefits when it comes to deploying EVPN. First, NSO is completely model-based, providing a simple way to create high-level abstractions for complex end-to-end configurations. Second, NSO provides state convergence, ensuring that configurations can be updated and deleted with minimal diffs across the network. The NSO EVPN model that I'm demonstrating today has two parts: Ethernet segments and EVPN services, both of which can be managed independently. For example, you can add or delete interfaces from a given Ethernet segment or change the load balancing type without changing the configuration of a service that uses that Ethernet segment. NSO takes care of the details for you. The most fundamental part of EVPN is the Ethernet segment. An Ethernet segment is just the set of links that connects the end customer to the provider edge. As we said, EVPN ensures that you can have multiple links in these Ethernet segments, and they can all be active at the same time for a truly redundant and load-balanced Ethernet service. Now, while Ethernet segments look simple to the end customer, the network has to do a lot of work to make sure that protocols and forwarding stay in sync end to end. As you can see, there are lots of lines of config with parameters that need to be coordinated across all the devices that terminate an Ethernet segment. In our NSO model, the Ethernet segment config is reduced to the simplest possible set of input, a list of devices and interfaces participating in that segment. That's it. NSO ensures that the rest of the required parameters are correctly allocated and pushed to the end devices. Instead of 9 lines of config per device in the segment, this model only requires 1. Once you've defined your Ethernet segments, you're almost done, because EVPN services are really just different ways of combining those segments. A virtual private wire service, or pseudowire, is exactly 2 segments. A bridge is more than 2 segments. An integrated routing and bridging service is a bridge with a routed interface configuration. Let's take the simplest example of a virtual private wire service. As you can see from these router configs, there are lots of parameters to coordinate and rules to remember, to the tune of 7 lines per device per pseudowire. Now contrast all that with the NSO model, where all you have to do is come up with a good name for your VPWS service and specify a pair of Ethernet segments. If you want multiple services on these Ethernet segments, specify a unique VLAN identifier for each one. 3 lines of config, 3 services. NSO ensures that every parameter on every device is configured correctly. With the same NSO model, even more complex services like bridges and IRBs are equally simple to configure. For a bridge, specify more than 2 Ethernet segments. For an IRB, add the parameters for your layer 3 interface to the bridge, and you're done. This may look like magic, but it's really not. EVPN works according to well-established protocols and rules. It's just that that's a lot for a human brain to keep track of and reason about at the network level. But by identifying the right high-level abstraction and implementing it in NSO, you can radically simplify the deployment process and get your end-to-end services working faster. In short, NSO makes EVPN even better.